My name's Luke. Call out to everybody who's here for their first time. I came for my first time last month, and I got roped into this. Hey, welcome. So I've taken that this means this is I'm hoping it means this is a welcoming crowd.
It is.
Very good. So you might be wondering. Yes.
Right, cool.
You might be wondering, why should we talk about Python on Windows, especially after that nice introduction? For my own background is I've been working with a particular Python app for a number of years now. I guess I was coding Python before it was cool. Started working on Linux. But there was a season, perhaps it was particularly in the financial sector, where Microsoft Technologies and the Windows Server was very popular, and I think probably the survival of the product that I was involved with, in some part, was due to the fact that we were able to deploy our Python app onto Windows. So I'm very grateful that Python runs on Windows and can work on Windows. And I've learned something about Python on Windows over that time. Why are we talking about that today? Well, someone noticed at the last PyCon, talking to particularly a lot of teachers and people involved in education, was that actually a lot of people's first introduction to Python is on the Windows platform. Or a lot of people's first introduction to coding at all is on the Windows platform. So I think this is a platform that's actually worth us caring about and making the Python experience good on. So obviously my own background, because of my own background, I'm not going to be talking to you about developer experience so much, what might be used, what development environments to use. I want to actually get into some of the lower level details about Windows and Python on Windows that I've bumped into in deploying Python on Windows. Hopefully, yeah. So here's some of the topics I want to talk through. Just to start off, here I've installed. Let me see if I can make it bigger. So I've installed here Windows in a VM on Ubuntu because it's easy to get to. This is pretty much a fresh install of Windows 10. There are actually a few different ways to install Python on Windows. What I'm talking about here is the installer that's on python.org. One of the first things you notice about Windows is you can't do apt-get install, apt install or yum install. There's not a package manager built into Windows. Interestingly, that space has changed a bit lately with, for a while there's been a tool called Chocolatey, which is a third-party package management tool on Windows, and Microsoft's trying to get on board with that a bit. There's also Microsoft Store, which is more like the Apple Store for iPhone apps. Anyway, but still, a lot of the times, software you basically run an installer. So I've actually already downloaded the Python installer from the Python website. Let me show you something. If I go to that, this is the folder, my downloads folder. Notice here that it mentions it's a type application, but see that name there doesn't have a file name extension. That's one of the things I've noticed about a fresh install of Windows. You don't see file name extensions, so one of the first things I usually do on Windows box is come to the folder options and untick this box that says hide extensions for known file types. Maybe that's just me, but I like to see what I'm looking at. So this installer has actually been there for Python for a long time. It takes a moment to load. Here we go. Don't run smart screen. It's trying to.
No, I think that was asking whether you actually want to run.
Oh, whether I want to run. I pressed the wrong button. Yeah. So this is actually trying to call home to Microsoft. They've got a feature in there. I've installed their home version of this, which checks that you're not downloading malware. So antivirus is also something we run into on the Windows platform. But we'll get back to that a bit later. So. One thing I've noticed about this installer is in more recent versions, it's defaulted to install to a strange location. It's maybe appropriate if I'm installing for just my own user, but if I'm installing for all users, it's not so appropriate. So what I usually do is customize the installation next through there, and I change this install location to what it used to be, which is
there's a checkbox at the top there.
At the top, install for all users. Yeah, cool. I still like that being there. There we go. Do you want to allow this app to make sense to your device? Yes. So one of the cool things that Python comes with is a tool called pip, and that even works on Windows. The first thing I might just mention though is is shell. So I mentioned there were a few different ways to install Python. I've got something here called Cygwin. That's quite an old tool that essentially tries to provide a Unix-like environment on Windows. It's worth being aware that Python on Cygwin is not Python on Windows. It's a very different beast. So don't run, I recommend not to run Python on Windows. Another thing to be aware of is that when I open this Cygwin window, this is not a Windows console. So you'll see in a minute, if I might just wait for that install to finish. It's pre-compiling the standard libraries, which is very nice of it. This is something that it does when you install for all users, so that the PY files are running. So I think I'll be able to do this straight away. Python. See, when I run Python, it just hangs there for me. I could actually start running some Python. Print 1 plus 1. Terminate. I can't actually exit the shell. Yeah. The reason that's misbehaving is because I'm not running it at a console. So this Cygwin window, essentially the standard output of my programs are being redirected into this Cygwin terminal. It's based on a program called IRESS. So for Cygwin apps, that's great, but for true Windows apps that expect to be running at a console, this is not a console. There are console replacement apps if you don't like the built-in console. One of them is called Commune. It's worth being aware of that difference. If I run Python from the runtime set, see this is the regular Windows console app. There are actually some system calls about consoles. So if you want to do things like stop the cursor echoing passwords, that's interacting with a Windows device called the console. Here we go. I'm going to close that. There's another shell called PowerShell, which is a newer version on the old DOS-like command prompt. Yeah, it's something different to learn. So here I already have a tool called pip. So I can just do pip install, say let's install a particular version of LXML, and that should just install it for me like you're accustomed to, which is really nice. There you go, it's downloading itself on that sort of thing. So the whole SyPy repository is generally available. It works in command prompt as well, yeah. The thing to notice about what this has done, so a lot of the time on Linux, if you're installing a package that has got a C extension, it's going to compile the C code into the C extension, whereas here, when I've installed Windows, I haven't got a compiler. I mean, if I'm a developer, I might go and install Visual Studio. There's even a free version of Visual Studio that includes compilers, but most users don't have Visual Studio installed. So generally, if you're publishing a package for Windows, you need to publish a wheel, a Windows binary. So if you looked up the SyPy page for LXML, you'd see there'd be a Windows version for it. Yeah. So now when I run Python, I can do from LXML. This is from string, and do from string to. There you go. Sorry, that's tiny writing, isn't it? Let me make it a bit bigger. I'm pretty much just the properties, font, to be, let's try that. I don't know about the shortcut. There we go. Is that bigger? Can you see that? All right. Yeah. So 64 bucks. Now let me just open another PowerShell. I want to show you something. So I'm not going to do the same thing because I've got another shortcut. Quickly. What do we say? 24. That's quite reasonable. Let's put that one by the shortcut because it's owned by, not by me. So now what I'm going to do is do pip install -- upgrade LXML upgrade LXML. So this should upgrade to the latest version of LXML, which is 4.1, right? Let's see what happens here. There we go. Oh, I got some yucky error that you can hardly read because of the blue background. What this is telling you, let me highlight it so you can perhaps see it better. It says permission error, win error file, access is denied, and then there's a long path to LXML e3.something.pyd. The one thing is that the .pyd extension is effectively a DLL. So on Linux, Python extensions are called .so, but on Windows they're called .pyd. But it's basically the deal of file format. So it said access is denied on that PYD file. So let me tell you something about accessing file permissions on Windows. All right. So let's start here. So I'm going to talk you through a bit of a history of file permissions on different platforms. There's a collection of platforms that are related to DOS and OS2 and Windows. There's another collection of platforms that are related to Unix, Linux, which is a clone of Unix, and Mac OS X, which is essentially derived from Berkeley, FreeBSD and Berkeley things. So in the beginning, with traditional Unix, there was, I think a lot of people here are probably familiar with that. You can use chown and group to set the owning user and group of a file, and then you can use chmod, which essentially sets the permissions on a file. So you control read, write, execute permissions for the user who owns a file, the group who owns the file, and for everyone else. That's the permission model. There's a few other tools, like there's a umask that you can set on your process, which basically controls when that process creates a new file, what's the default permission going to be. There's some more advanced things like this set UID and set GID bits you can set on a directory. So if you set that bit on a directory, it means that if you create a file in that directory, actually it's going to be owned by the user or the group that owns that directory rather than whatever the umask says. Yeah, there's some details there which I'm not going to get into because this is about Windows. But that's what Unix had. Meanwhile, what MS-DOS had was no concept of users, and there's this Boolean attribute on files you could set called read-only. So if you set the read-only attribute, you couldn't overwrite the file, unless of course you cleared the read-only attribute on the file. So that was the first round. So the next thing that happened was NTFS, OS2 as well, introduced these access control lists on files. So what that's about, that's essentially a lot more complicated. So there are different subjects that you can grant permissions for. So you can give permissions for a user. It can be any user or any, whether it's domain user or local user. So there's this thing called domains in Windows, particularly if you're part of an organization where you can have a central server that manages your identities, an Active Directory server, and that's where users are created. Effectively, these users end up getting mapped to something called a security identifier, or a SID, which is really just a long string with numbers in it. So the mapping of usernames to SIDs is something that can be done with Active Directory, but the ACL actually, under the hood, it just refers to these SIDs. Anyway, you can grant permissions for any user or for any group. There are also a few well-known SIDs like everyone or the creator owner on the file. There is a concept of owning, of the owning user and the owning group, like on Unix, although it's not really used quite so much because the permissions are so much more flexible. But also, instead of just having read, write, and execute, there's 14 different permissions you can set on files and directories, or 13 for files and 14 for directories. And you can also allow, the rules can be an allow rule or a deny rule. Like you might put a deny rule, this user just can't touch it, whatever any of the other ACLs say. There's also a concept of inheritance. So if you set permissions at a high-level directory, you can mark that they should be inherited by files or directories underneath. So by default, this essentially replaces the umask or the set UID thing. It's a way of setting default permissions for files underneath. Notice it's about the directory, it's not about the process. Okay, so the Unix world responded with something called POSIX ACLs. This was essentially what the standard that was agreed upon after a few vendors like Sun had their own shot at doing their own thing. So it's similar to NTFS in that you can grant permissions for the owning user, the owning group, or some other user or some other group. However, it's different from NTFS in that the permissions you can grant are the same as for traditional Unix. So you've got the three: read, write, or execute. You can set default ACLs on the directory, which is a bit like NTFS inheritance, not quite. That's POSIX ACLs, the late 90s. And then more 10 years ago, I think it was, they came up with this new concept of NFS v4 ACL. So this comes from Unix servers wanting to be able to publish file shares to Windows systems. So NFS v4 ACLs are very close to NTFS ACLs. And therefore they have grain permissions which match the 14 permissions you have on NTFS. So there is some support for this on Linux and on Mac. So that's where we are now. Can you put your hand up to anyone who's actually, whether it be on Linux or on Windows, has ever actually looked at ACL when setting up file permissions? Not too many, that's cool. Not too many. It gets very complicated very quickly. And generally, you're just trying to do something very simple and it's too complicated. 0600, yeah. So what can we use in Python? In the standard library, there are a bunch of functions in the OS module. There's OS to mod. To mod is like Linux command chown, umask, which are like the commands that I mentioned before. You can also do it on file descriptors, which I'll come to soon. So that's on Linux. On Windows, out of these, only os.chmod is available. At worst, it only controls the read-only attribute that I mentioned at the beginning. That's the only thing it manipulates. Not heaps useful. There is this package that you can download, which has been supported for a long time, called Pylin32. This exposes a lot of the Windows API concepts to Python. So with this, it's possible to interact with NTFS ACL. So for instance, there's this function called getNameSecurityInfo, which is about get to the ACL for a file. There's this documentation on MSDN, which is essentially for the C function. So you can read all about this function here and the parameters it's supposed to provide. And then in Python, there's a function called Win32 Security, which has a matching function called getNameSecurityInfo. So a lot of the Windows APIs are available through one of these Win32 modules. It's a bit tedious, so you rarely actually have to deal with this. It's worth knowing about ACLs though when you start getting permission errors and you're trying to figure out what's going on. So let's go back to the problem that we had before. We had that permission error, if you remember. Let's have a look. So we had a permission error. Now, you probably can't see this file, but I can read it if I look closely. So I'm going to try and go to that spot. So it's C users data temp. So the Python wheel actually contains the PYD inside it, but for it to work properly as a DLL, it needs to be extracted to a real file so that you can load it to DLL. That's why I'm going to the temp folder here. So the previous version of LXML was extracted here, and there was this PYD. And then where am I going under here? It's pip something, pip, not that one, uninstall, Python 36, LXML. Now, I'm not sure if you can see that text. That text is quite small too. So here I have this PYD file that's contained there. What I'm going to do is right-click and properties on it. So this is how you can inspect the ACL. So because ACLs are so complicated, they try to hide it from you. If I get the security type, that's the wrong file. Right, wrong file, did I? What have I got? I need eTree. This one. Excellent. Here we go. Security. See, here's a simplified view. It tells me that authenticated users have. I'm going to jump straight to the details. So if you click Advanced, you get to this screen, which has got another view of it. I'm going to press Add just so that I'm not going to add something, just so you can see all the permissions. If I select the principal as a person, I'm going to put myself, and you can show advanced permissions. See how they're hiding it. There's my list of. Well, it's 13 because this is a file. There's all the different pieces of things in the file. I'm not going to go into all those details. Let's close that because I don't actually want to just add a permission. But this is, another thing you do is effective access. So it lets you actually see what access a particular user has. So let's just see what access I should have to this file. So, that work, view effective access. It says I should have full control. That's interesting because we got an access denied error, didn't we? That's the segue into our next topic. So this probably isn't actually about file permissions.
Can I just ask a random question at this point? Could this all be solved by running PowerShell as administrator?
No.
Right. Cool.
Yeah. So there is a concept of elevation in Windows that I want to get to. Anyway, layers of file abstraction. So just a bit of a, I'm not sure if you've seen this before, but you know, in Python, you've got file objects or stream objects, returned by open or by io.open, different ways to get them. So that's a layer on top of, in a C standard library, there is this file struct pointers that you deal with, and you use functions like fopen or fwrite or fread in C program to deal with these files. And that, in turn, is a layer on top of the system call interface, which deals with file descriptors, which are just integers, those numbers. And there are system calls like open and read and write that deal with those files. Just by the by, while we're here, Python's OS module can work with these file descriptors. So there are, for instance, os.fdopen gives you you give it the integer file descriptor and it gives you back a Python file object, wrapping that file descriptor. There's more functions in the OS module. So that's the 3 layers you have in Linux. Windows has another layer. So besides the 3 I mentioned, so the Python file objects, the C standard library, file pointers, file descriptors, which are the integers. It's worth noting that the file descriptors are actually implemented in the Microsoft C library. They're not the kernel level thing. They put that in for POSIX compliance back in the 90s when they were trying to get people to port their Unix code to Windows. What the system interface deals with is Windows handles. So there is a type in SQL caps handle, which is actually a void pointer. And there are functions like create file, write file, read file in the Windows API that used to deal with these. So one of the modules in this PyWin32 package I mentioned is called Win32file, and that's a function called get OSF handle. So this, if you give it a file descriptor, it can give you the underlying Windows handle if you want to deal directly with that. One of the interesting things about how create file works, so unlike Linux, concurrently opening the same file from different processes is restricted. So by default, there can only be a single writer or multiple readers. So actually, this is the problem I'm getting here. You would have noticed, I'll just skip back to here. I've still got my window open here where I've used the lxml.etree library. So because this has the PYD file open for reading, that means another process cannot open that file to delete it. And so pip install was trying to delete the old version and bumped into that. This is something that I noticed breaks a lot of software that was written for Linux. It's something that's really worth being aware of. There's little things like using with when using a file rather than trying to rely on a garbage collection to clean up when you're finished with it. Little things like that can help. Just being aware of it, I think it's a start. Back to the presentation. This. So this behavior can be overridden. So if you're actually using the low-level create file interface, you can specify what sharing mode you want. So I'll click over to this documentation. So again, this is on MSDN, but the same functionality is available through the PyWin32. I'll make this a bit bigger. So one of the parameters to create file is this share mode. And so if I scroll down, you can say, I want this file to be, I'm going to let there be shared readers, shared writers, or shared deleters. It's possible to delete a file while somebody else has it open. That leaves the file in a weird state where it still exists in the directory and you can't get another file with the same name, but you can't actually open the file because it's quite different from the Unix model where deleting it is actually an unlink operation. That's what in the OS model is called os.unlink as a synonym for os. It's not unlinking on any of that. Something that's really helpful in dealing with this stuff is the Windows sysinternal suite. So if you find yourself actually working on the system and you want to understand what's going on, there are some really cool tools which are not included with Windows. You've got to download separately. But thankfully, Microsoft has now bought the guy that wrote these, and so you can download it from Microsoft. So there's this cool one called Process Explorer, which I'm going to show you how it's helpful. So you just go Google Process Explorer, and you'll find first hit Windows sysinternals. That's the one. You can just download it straight away. There's also Run Now. It downloads the executable. You can just run that straight. So if you're having to manage some Windows server that have internet access, just run some code. So I've done that on Linux, which is not much use. So I'm jump into Windows. So close some of this stuff. There we go. I'll go go to.
If you
Yeah.
close that Python shell, then you can just install it.
I want to show you this before I close it. In fact, if I ran pip install again, we'll be happy because it's already thinks it's removed. It's forgot that it still has to remove something. So, it used to be different before we used wheels. So when the PYD was actually written into the Python root folder, you'd have the problem repeatedly because it was trying to replace the same file. Whereas now each wheel is unpacked into a different temporary folder. It's less of a problem. It's just a way of illustrating this problem though, because it does show up in other contexts. Another context it shows up in is this is rotating log files. You've actually got to close all handles to a log file before you can change its name. What am I doing? Not Windows 10. I'm doing Process Explorer. I just want to show you what this looks like in Process Explorer. Go. Let's extract this to sys internals. There we go. Process Explorer. Yes, I agree with your license terms. Now, oh, this is very small again, isn't it? I can perhaps explain as I go. So see, as you see here, there's a bit of a tree view of all the processes running in the system. And if I was to pick any particular process, there's a bunch of different properties you can see, like what was the command line of the process, what the process ID is, all these properties about how much memory it's using, how many page faults it's had, what TCP/IP socket it has open. I think because I haven't run as administrator, it's not showing that to me, or maybe it doesn't have any TCP sockets open. You can look at the list of all the threads, and if you've got the right libraries installed, you can get thread stats of those. So there's a lot of detail in each process, and you can add those columns here if you want to look at them in the summary view. What I'm interested in though is somebody's got my PYD file open. So I'm going to do, see what I did up in the menu. On the find menu, there's something called find handle or DLL. So somebody's opened my PYD. So I'm going to type PYD. Well, how about I type E-tree? I'll type E-tree. Now this is searching through all the processes to find who's oh look, here's one, python.exe process ID 5736. Let me click on that. So in this lower pane view, there's two lower panes you can get. This one here is a list of all the DLLs, and look, it's got that DLL open. So there's my culprit. I've got to close this process before I can remove that file. There's also another tab, if I come in here, lower pane view, handles, that shows all the handles that this process has open. One thing to point out, see, there are file handles and directory handles. There's also other kinds of handles. So thread handles, window station handles, basically any kind of system object you reference with a handle. A lot of different kinds of system objects can also be controlled using access control lists like files, although sometimes the specific permissions are different. So one thing I've glossed over is the registry. So the registry is a way of configuring stuff on Windows. You can put ACLs on registry entries. Yeah, that's Process Explorer. If you're a command line guy, there's a similar command line tool called handles.exe, which is also from systemterminals. It just tells you what processes have got what handles open. The interesting thing is it doesn't tell you about the DLL. So in this case, see, there's not a file handle for that DLL. So handles.exe wouldn't have helped me. Okay, that's Process Explorer. So some other tools that are useful, I'll go back to my presentation. Some other tools that are useful. Oops, I'll skip to the end. And then another one that's useful is process logging, which is a bit like strace on Linux. So if you want to see all the system calls that a process is making, that's what that does. I showed it. I wanted to mention something about sockets. So one of the big differences on Windows is that sockets are not file descriptors. So on Linux, socket file descriptors are integers, just like file, real file descriptors. It means you can use them in all the same kind of calls, like select, for instance. Yeah, but the fact that they're different things means that the select module in Python, for instance, and also libraries like gevent, I know that was mentioned last month about, that's a way of making async I/O look like it's threaded I/O. But you can't mix socket and file I/O with these libraries on Windows, even if it does it on Linux. In fact, the whole story around async I/O is a bit awkward. So high performance async I/O is available on Windows, but it's quite different than on Linux. And what that typically means is that people who are mostly interested on Linux and do Windows ports a bit of an afterthought, like Nginx, often don't have very good behavior on Windows because they're just using select where their APIs available. That's what I want to cover. Any questions? Of course, there's a lot that I haven't covered. I'm interested in what questions you have or experiences you want to share with yourself.
So when you had that process ID, and it's 573 or whatever it was, then you go ahead and how would you then find that process ID in the code?
Yeah. So I mean, I happen to know which process it was because I knew I had Python running. But you can also in process support you can directly terminate processes if you want to. Yeah, that's right. So whatever. And you can also see the tree gives you some idea of maybe if somebody else was logged into the same server as a multi-user system, you could see it underneath the Windows station. There's a lot of other information you can get to try and figure out who launched it, why it's there. But you can terminate it directly. Sometimes if you got the thing that I didn't mention about processes is that there's no fork on Windows, which is another difference. They have the system called create process. It's like spawn. But if you generally want to do a fork, like cwin make or cwin bash even, cwin in trying to present a layer that's like Unix has to go to great lengths to emulate fork by launching the process, suspended, and then trying to map in all the same mappings. But if you happen to have a real-time antivirus tool installed that preloads its own DLL into the process as soon as it's created, then that could clash with something we're trying to map in, and so you're unable to do the fork. Yeah, so basically it's shy like when you sort of design it in fork, which involves using make.
So multiprocessing that doesn't work.
Multiprocessing module in Python works.
How does it work without a fork?
It spawns.
It's spawn.
Okay.
Yeah.
Just want to make it clear. Do you know, have you ever had to do with like vector or something like that?
Vector, no.
Corporate policy thing, where we can out of work, like some guys can't even install a printer code.
Oh yeah, so in terms of policies, often in a desktop environment, this can be quite locked down by administrators if you remember correctly, so that can stop you doing a lot of distributed things, like maybe even installing a printer drive. It's also antivirus tools can also get in your way sometimes. One example that I've noticed is if you create a file, write to it, and then close it, if you think you can open it again soon, just be aware that the real-time antivirus would have opened it as soon as you close it, and it's scanning it. So there's a gap of time in which, because of that file sharing, the open file sharing thing that I mentioned before, you can't actually access that file, that scenario. So an example of that is even the C language linker. So if you need to link a program, produce an executable file, and then shortly afterwards you want to edit the file to add some more information into the file, that can fail if you've got real-time antivirus running.
Yeah, I ran into that.
It's good to understand why these things happen. Yes?
Are any of the other Python distributions any better, like Active State or Anaconda for Windows?
At this stage, it's been around for a long time. It's got things like Power32 installed by default. I think the most important thing is to get yourself a good development environment like PyCharm we use here a lot. Or Visual Studio is actually really good with Python these days because it's popular in the non-Py community. Yeah.
Last question. Oh, yeah, last question. And we'll go for it. And then we'll get
Just curious, with the new visualizer that put into Windows, does that change any of this, or is
Yes,
that just a layer between the underlying doesn't matter?
So this changes many of these things. This is reviving something they had back in the 90s, which was the Unix emulation layer. So essentially the Windows kernel can provide different system call interfaces to different classes of processes. So that actually runs the real Ubuntu userland binaries, making Linux system calls. And the Windows subsystem for Linux in the Windows kernel can handle those system calls for those processes. So your userland is all Linux. Properties of the file system still apply to you, so you'll still have trouble concurrently opening a file that a Windows process also has open. But between different Linux processes,
and that's what happens when you have a lot of money destroying kernel problems. By the way, you should know that Windows shipped with Yes, Windows itself shipped with Python built in 1996. They had an IRESS thing they couldn't generate CGI, so they had Python built into Windows. That's kind of cool. Well, we've come a long way since then, and thank you, Luke, for actually illuminating a lot of file conditions and sort of, you know that How I Met Your Mother has that glass crashing thing. Yeah, I had a few of those. Thank you, Luke.
Thanks, guys.